Hello, my name is Paul, and this is my submission for CS50AI project Crossword, where we have implemented an AI that can generate completed crossword puzzles. And so what we're doing here is providing our algorithm with a structure file, which contains an empty crossword puzzle to fill in. Blank underscores represent the blank spaces, and hash marks represent spaces that aren't to be filled in. We're also giving it a list of words that it can fill those spaces with. And then we are running a backtracking search algorithm in order to find words that will fill the crossword while maintaining the constraints that are between the words. I mean, essentially, we're treating the crossword generation as a constraint satisfaction problem, where the words the variables are the words to be filled in. The domains of each variable are the words in the word list. Each variable has some node constraints, such as the length of the word must match the length of any word that's in its domain, and it also has some arc constraints, which is when two words overlap, characters are going to need to match on certain indices for each variable. And so overall, when we run our algorithm, we are going to first of all enforce node consistency, and then arc consistency, and then finally run a backtracking search. Now I've edited the way the program runs slightly so that I can choose between running a regular search, backtracking search, or an interleaved backtracking search, where we alternate assignment of a variable and also running the AC3 arc consistency algorithm. And we can show that has some efficiency benefits when you do the interleaving. So let's quickly run through some examples. If I set this to true, we're going to run the interleaving algorithm, and we'll start with structure 0 words 0.text, which is a simple structure and a small list of words, and you get a very quick result, which I can show the output of here. Then we can move on to structure 1 words 1. So structure 1 is a bit more complicated, and words 1 contains about 40 words. Sorry, structure 0 words 1 is so still the simple structure, but with around 40 words now to pick from. And again, we quite quickly get a solution there. If we go to structure 1 words 1, we have a slightly more complicated structure now, but still can quickly find a solution for this problem. And now we can move on to structure 2 words 2. And again, this is a different structure, and the words list 2 actually contains, I think, around 3,000 words, so a much bigger word list. But again, this very quickly finds a solution with the interleaved assignment and arc consistency enforcement. So I've actually created a much bigger structure file, which we can try to solve using the largest words list available. And this can show the efficiency improvements of the interleaving algorithm. So if I run this, first of all, with the interleaving algorithm, it takes a second to load in, but we quite quickly will get a result. And now, just because I know this will be slow, let me quickly run this without the interleaving. False. So this can quite quickly find a result with the interleaving algorithm, and it actually only took 24 calls to the backtracking function, and only 23 words actually required to be assigned, because as we're assigning each word, when we enforce the arc consistency, we're removing words from other domains that would not be consistent with the assigned word, and so it quite quickly limits the available domains of each variable and helps us to not make an incorrect assignment. Now, when we don't use this interleaved algorithm, the domains stay quite large after the initial round of node consistency and arc consistency enforcement, and so it quite often will give you a wrong assignment, causing multiple calls to the backtrack function and many more words that require to be tested. So yeah, that's my submission. Thank you very much for watching this.